Alright everyone, welcome back to the day 17 of our daily leetcode challenge, and today we have got neighboring bitwise XOR. So let's try to understand the question. What they have provided us with in this question is that they have provided us with an array called as derived, and it's a binary array, meaning it has values ones and zeros, and they want us to find an original array such that each element in its index is the bitwise XOR of a neighboring element. So what they mean by that is, one right here is going to be the bitwise XOR of elements. Let's say this is our derived array, and this is our original array. They want us to find us the original array from the derived array, so that each element here 1, which in this case 1, is a bitwise XOR of these two elements. Each element is a bitwise XOR of its neighboring, the one and the element coming right next to it on the right hand side. In the case of last index, it's going to be this value z and the value x. So in this case, all these values are something like this. They have provided us with, so in this case, x XOR y is equal to 1, and y XOR z is equal to 0, and z XOR x is equal to 1 in this case. Similarly, if we take this example right here, we will have 1 comma 1 comma 0. So they want us to find, this is our derived array, they want us to find an original array which is of equal length, and this array will also be a binary array of x, y, z, where the first element that we get is the bitwise XOR of x and y, so we get 1. The second element is the bitwise XOR of y and z, we get 1, and the last element is the bitwise XOR of z. And since for this element the right hand side is no element is available, so we're going to take the element on the last the 0th index from this side. So it's going to be z XOR x, which gives us 0 in this case. So we need to find those ones and zeros in place of x, y, z. So now let's try to take a look at all the examples that they have given us and try to understand if we can find a pattern in them or not. So let's see. Let's take the first example. The first example that they have provided us is 1, 1 and 0, and the original array that they have provided us is 0, 1, 0. They say that 0, 1, 0 will be the original array for this derived array. So, and it's true, because if you see 0 and 1 XOR together will give us 1, so that's why we get 1. 1 and 0 XOR together will give us 1, 0, and for this 0, the element that we're going to choose will be this 0 at the 0th index. So 0 and 0 will give us 0. So that is why we are getting 1, 1, 0 as the answer for the first example, and it's a true as well, because for this original array we get the derived array, so that's why it's a true. And for the case of 1 and 1, we see that the derived array that they provided us is 0, 1. Now the reason behind that is, we XOR 0 and 1 together, we get a 1, that's why we saw 1 here, and for this one we XOR it with this 0 right here, so it becomes 1 again. So that's why the XOR is 1 and 1. This is the derived and this is the original. Now let's also take the example of 1 and 0. For this they were not able to find a derived array. The reason behind that is, you can get 1 XOR 1 as a value. Let's say we take a array 0 as 0 example, or 0 and 1 as example. If we take 0 and 1, we will definitely get the first element, because 0 XOR 1 is 1, we got that. But for the last index we require a 0. If we have a 1 here, we must have a 1 at the first index, or if we had a 0 here, we must had a 0 at the first. But if we have a 0 at the first index, this condition is not possible and this is possible. So this kind of contradicts. If we want this value, we can't have a 0, and if we want a 0 here, we can't have a 1. So because of this, they returned a false. Now let's try to understand how what are like in the cases of derived cases where we had a true. Let's try to find some properties in them, in those derived arrays. If we take a look at the derived arrays, right, they could be, one thing is for sure, that they are all binary arrays, meaning they are of zeros and ones. Now if we XOR all these values of the derived arrays, let's XOR all these values, 1, 1, 0, 1, 1, 1, 0. So 1 XOR 1 gives us 1, and 1 XOR 0 gives us 1 XOR 1 gives us 0, and then 0 XOR 0 gives us 0. So finally the XOR of all these values is 0. In this case also it's 0, and in this case also, and this case, but in this case it's gonna be 1. Now let's take, now if you notice, we know that the in a case where we only have ones and zeros and the XOR values coming in as 0, that means for sure that 1 appeared an even number of times and 0 appeared an even number of times, because that is a property of XOR. On any number XORed with its own an even number of times will give us 0, and any number XORed with itself odd number of times will give us 1. We saw that property on the previous question as well. We can quickly see that property here. If a value is XORed an even number of times, it gives us 0, and if a value is XORed an odd number of times, it gives us 1. So if you take a look here, let's say I am taking A as example. A XORed 4 times will give us 0, because any number XORed with its own is 0. So these two become 0, and 0 XORed with 0 is 0. Let's say A is XORed 2 times, again 0. A is XORed, let's say 6 times, it will still be 0, because all these values right here will turn to a 0. This value turns to a 0, and eventually XORed with this value will give us 0. So any number XORed an even number of times is 0, and any number XORed odd number of times is the number itself. The reason behind that is because the odd number is an even number plus 1. So all the XOR values up till the even part will be 0, and we XOR that original one single element with a 0, then we will get the same element back again, because this is the identity property in XOR, in a binary, the identity property of XOR. So any element XORed with 0, you will get back the original element. So that is why an element XORed an odd number of times gives us the number back itself. Now if you see, right, we saw that the elements which are derived arrays which are returning true are all having the XOR values as 0. We just saw that, like this is a pattern that I'm seeing here, and we can use this pattern to get the answer. Let's say that I have another array which looks something like this. Let's take a bigger array. How many even counts how many ones we have and how many zeros we have? We have a 1, 2, 3, 4, 5, 6, and we have 3 zeros. Let's add one more 0, so the count of both 1 and 0 is even. Now if you try to do the XOR of all these elements here, the answer will be 0. The answer will be 0. And why? Because again the count of ones and the count of zeros is even. Now there's one more thing. If the count of 1 and the count of zeros is even, this means that the sum of all these elements in this binary array will be divisible by 2. Since the count of 2 and the count of 0 is even, you add any number x and y which has even frequencies, right? And if you add them, if you add all the numbers, it will eventually be divisible by 2. So these are the two properties that I'm seeing for a derived array which is valid. All its XOR values will be eventually be 0, and since it's 0, the sum of its values will be divisible by 2. In the case of 1 and 1 as well, we saw that the sum is 2 is divisible by 2 and the XOR of its values is 0. So using this property right here, we can conclude that if the sum of all the values in a binary array is divisible by 2, it will have a valid original array. Now can we form a valid original array for this one? We can, because if you see, let's say we started with a 0 and we need a 1 here. So 100% on the next element we're gonna need a 1, so we add that. We need a 0 here, so 100% for this element we're gonna need a 1, we add 1. Then we have a 1 here, then on the next element we need a 1. So this is gonna be XORed in the next element, so we'll have to add a 0 for this element to be formed. For this element right here we need, so this needs to be XORed to be with a 0. Then we need a 0 again on the next element. So this element will have to be XORed, these two elements will be XORed to get this. So that's why I added a 0. Now again we need a 0, so this has to be XORed with a 0. 0 XOR 0 will give us 1. Now we need a 1. So this has to be XORed with 1, there is no other option, we get a 1. We need a 1 back here, so that what element to be XORed here so that we get a 1? The answer is 0. And what with this one? What do we need if we need a 1? They will have to XOR a 1 here. And what about the last element? this last element right here will be XORed with this value. What can we XOR here with this value so that we get a 0? The answer is 0 again. So we see that if a derived array will 100% have an original array if its sum is divisible by 2, and it's like the first property is the if it's a derived array, the XOR value, if it's appearing by is if the XOR of all its values is turning out to a 0, the sum of all its elements will be divisible by 2. So these are the conditions that go hand in hand. If the XOR of all the elements is 0, it means that the sum of all the elements is going to be divisible by 2. So we can do either or. Either we can XOR all the elements, or we can add the values of them and divide by them by 2. Either case, if one is true, the other one will also be true basically. So we need to check just that, and if that's the case, then this array will 100% have an original array that we just saw. Same case with 1 and 1 as well. We saw that the XOR of its all its element is 0 and the sum is also divisible by 2. So both these conditions are true. We just need to check one. If this is true, this is also true. If this is true, then this is also true. It's like a complementing property. If this is true, then this is also true. Now we said that if these conditions are true, 100% we're gonna have an original array. So let's see how for 1 and 1 we got 0 1. We started with 0. Now to get a 1 on the next side, we'll need a 1, and for this one we'll need to XOR it with the next element. So this is also getting satisfied. So that is why we had 0 and 1. So eventually we just need to return a single line for this solution, and that will be to return if the sum of all the values in derived is divisible by 2. Or we could also do an XOR, but that would be kind of lengthier. So let's just quickly return if the sum of all the values in derived is divisible by 2. If this is true, we just return true. If it's false, we return false. And if we try to run this, we'll see all the test cases are getting passed. And if you submit this, see, so this is a pretty efficient problem as well. This is a O of n and O of 1 space, because we are not using any extra space, and a sum is going to be a linear solution, a linear time complexity. So that's why the O of n will be the time complexity of this one, and O of 1 space. So this was it for today, everyone. I'll see you guys tomorrow. Bye.